All right, so good news. This is our last section of 4.4. So hopefully that's good news. And this one is going to be talking about parallel and perpendicular slopes and how do I write equations that are equations of lines that are either parallel or perpendicular to a given line. Okay, so to be able to do that, I need to recognize what happens when I have parallel and perpendicular slopes. Okay, parallel and perpendicular slopes. So let's go ahead and take a look at parallel lines. Okay, parallel lines are two lines that don't intersect. So if I have a line here and a line here, they are never going to touch. Okay, they're never going to touch. So they actually have the same slope. So if my slope was 2 over 1, the parallel slope would be 2 over 1. Or if my slope was a negative 2/3, the parallel slope, and notice the symbol, that means parallel, is going to be a negative 2/3. Okay, so they're exactly the same. Exactly the same. Now, if I have perpendicular lines, that's different. So here's one line, here's the other line. So the first thing I want you to notice is this one is positive and this one is negative. So that's one big issue. Okay, they flipped in terms of sign. And then the other thing that is going to happen is the numbers are actually going to flip. Okay, so let's say that my slope is 2/3 on this positive line. My perpendicular slope, and look at this symbol, that upside down capital T means perpendicular. The perpendicular slope is going to be a negative 3/2. Okay, negative 3/2. So we're actually going to flip and switch the sign. Okay, we're going to flip and switch the sign, and that is called an opposite reciprocal. An opposite reciprocal. So if I gave you a slope of 5, or let's say negative 5, then remember that's over 1. The perpendicular slope would be a positive 1/5 because they have to flip and change signs. Okay, so parallel is the same. Perpendicular is flip and switch. Okay, flip and switch. So make sure that you have those examples written down and those definitions. And then go ahead and I want you to hit pause here and I want you to determine what my parallel slopes are and my perpendicular slopes to these problems. So hit pause and get me some answers. All right, let's see how you did. Okay, remember, when we're talking about parallel, that is the same. Okay, that is the same. So if this one is 3/4, then this one is 3/4. If the slope is -3, the parallel slope is -3. And if the slope is 0, the slope is 0. So finding the parallels is really easy because they have to match. Okay, the perpendiculars have to flip and switch. Okay, flip and switch. So let's go through those. So I know this is positive. So I know this one's going to be negative, and I have to flip the numbers. So that would be a -4/3. The next one, remember, this is over 1. I'm going to flip the sign, becomes positive, flip it, 1/3. That is the perpendicular slope. Now, this one is interesting because I might have to think about this a little bit. If m is 0, that means my line is horizontal. What does the perpendicular look like to a horizontal line? Well, it's one of those. Okay, it's one of those, which means if this is technically over 1, then this would be 1/0. Can I divide by 0? That's not possible. So it's not possible, so the slope is actually undefined. So that is that special case, okay? And vice versa. The perpendicular to an undefined is going to be 0. All right, Now, how do we find equations of lines that are parallel? And how do we find equations of lines that are perpendicular? Okay, so really the only difference, we're going to use our point slope form, but the difference is we are going to make use of the parallel and perpendicular slopes. Okay, so the formula is exactly the same, except I'm using the correct slope. Okay, the correct slope. And I might have to find, if I'm given a specific point, I may have to actually find some slopes from there, or give it another point. All right, so I might have to still find slope. So write these two equations down. Here's your parallel point slope, and here's your perpendicular point slope. And then let's go ahead and look at some examples. All right. Here are my steps. Okay, here are my steps. Anytime I have equations, I'm going to have to find my slope from the existing equation or from 2 points. It doesn't make any difference. I just have to find the slope. Then I can find either the parallel or perpendicular slope, and then I can just substitute into my point slope form. Okay, so it really isn't any extra process. So write the equation that is parallel to y equals negative 5x plus 4. So the first thing we have to find is slope from our original equation. Well, the slope from the original equation is negative 5 over 1. Okay? And then we want the parallel slope. The parallel slope is the same, so it's negative 5 over 1 or negative 5. So at that point, I need to use this slope in my formula, my point slope form. Okay? So y minus, I'm going to go ahead and build my template here. And here are my x1, y1. So I've got a 6, I've got a negative 5, and I've got a negative 3. And the rules still hold. Okay, the rules still hold. Rewrite, watch your double negatives. So y minus 6, the negative 5, x plus 3. Y minus 6 equals negative 5x minus 15. And y equals negative 5x plus, take that back, minus 9. So here is the equation of the line parallel to this line. And I want you to notice that my slopes are exactly the same, and the b's are the only thing that is different. Okay, the b's are the only thing that is different. So why don't you go ahead and hit pause and see if you can do the next problem. And that is 1/4. All right, let's see how you did. So slope is 1/4 and parallel slope is 1/4. So y minus, here's my 1/4, x minus, drop in my numbers, there's a negative 1, here's a 4. So negative negative is positive, y plus 1, and this side is fine. So since this side is fine, I'm going to go ahead and distribute. So I have 1/4 x, and 1/4 times negative 4 over 1 gives me negative 4 over 4, which is a minus 1. If I move that 1, I have y equals 1/4 x plus 0, or y equals 1/4 x. I do not need to write the plus 0. So hopefully that's what you came up with. Now, keep in mind if I was to graph that guy, it's starting at 0. Okay? And it would go up 1 over 4, and there would be my line. So remember that if there's not a number there, it's still, that's what's starting at 0 for graphing. Okay, let's take a look at the perpendicular set. So write an equation of a line that is perpendicular to negative 2/3 x plus 5 and goes through the point negative 9, 4. Okay, so my slope is negative 2/3. Well, I need the perpendicular slope. So remember, this is a flip and switch. So it becomes a positive 3 over 2, and this is the slope I have to use now. Okay, this slope is gone. I have to use the correct slope. So y minus, I'm going to put in the perpendicular slope, and x minus, so here's -9, and there's a 4. So y minus 4. And if I want to start kind of shortcutting a little bit, I can see that, hey, that's going to be a plus sign. So I'm going to go ahead and make that just a giant plus sign and save myself writing that down a little bit. So I have 3/2 x plus. And I have 3/2 times 9/1, which is going to give me 27/2. Okay, 27/2. So I know that that is actually 13.5, and decimals are fine. I'm not solving to standard form here. Add my 5. So y equals 3/2 x plus 18.5, and that is my slope-intercept form. Remember, if I wanted to go to standard form, I would need to go back to this step where I would have to add that in. Okay. All right, go ahead and hit pause and see if you can come up with the next equation. We've got, write the equation of a line that is perpendicular to y equals 4x minus 8 and goes through the point 2, -1. See what you can do with that. All right, let's see how you did. So my slope is 4/1. I really have to think about that as being 4/1, and it's positive. So if I flip and switch it, it becomes -1/4. So this is the slope I need to be using, -1/4. So y minus -1/4, I'm going to go ahead and throw that in there. And I have a -1 and I have a 2. So negative is positive, y plus 1. This one I don't have to distribute anything. So -1/4 x, negative is positive. So let's think about what this is. -1/4 times -2/1 gives me 2/4. And that is actually a 0.5. Now I'm subtracting 1. So y equals -1/4 x minus 0.5. And I am finished. Okay, I am finished. All right, so let's see what you can do with parallels and perpendiculars. Remember, parallel slopes are the same, and perpendicular slopes, you have to flip and switch. Make sure you are using the right slope depending on what it is asking for. And next step is review and take a test. So hopefully you're feeling confident about linears at this point, and we will be moving into inequalities in Chapter 5. Have a great rest of your day.